Hello and welcome to my YouTube channel. This is Ramani Online Mathematics. If you know you have not subscribed, please subscribe, share to your colleagues. Please, when you watch the video, like the video. Thank you very much. Now we are going to look at Fourier sine and cosine series. Okay, already have looked at the Fourier series, and the previous videos that I've done, we looked at the computation of the Fourier series when it is even, when it is odd, when it's neither even nor odd. Now you are going to look at the Fourier sine and Fourier cosine series. So let's start with this. Given f at x on the interval 0 to L, this time around is not negative L to L but 0 to L, the Fourier cosine series denoted by, so this is how we write the Fourier cosine. Is the same f at x, but we put the small c as what? Subscript there. I hope you can see that. Is given by f subscript c of x is approximately 2. So this becomes the whole formula for the Fourier cosine. Is that okay? The Fourier cosine series. The a naught is part of the Fourier cosine series. Is that okay? Now, the formula for finding the a naught here, because it starts from 0 to L, it's not 1 over L, but rather 2 over L. And the an to the same thing, but it's 2 over L. Take note of it, because in exams when you have to use the Fourier cosine, you are going to use 2 over L. But if you have to find Fourier series, that one is 1 over L. Okay. Now, with the same preamble from 0 to L, our Fourier sine, so that one, the s is also subscript, is also given as this. Is that okay? So if I'm to integrate it, this is what I get. Bn. So you see, the Fourier cosine, the a naught and the an are together. So when you have to find Fourier cosine, you need to find a naught and also need to find what? An. And after that, you substitute. But for the Fourier sine, it's only what? The Bn. Then after that, you substitute. Is that okay? So this is what we are going to do. Now let's look at an example. Okay, now let's look at this example. Compute the Fourier sine and cosine series of the function f at x equals the absolute value of x plus 1 on the interval 0 pi. So we have to find both the sine and that of what? Cosine. So the sine first. So let's look at the Fourier sine. We know that for the Fourier sine, f at x is always approximate to the summation as n equals 1 to what? Infinity Bn sine n pi x over what? L. Right? So we need to find our Bn. So our Bn will be equals to 2 over L, right? But in this case, our L is pi. I hope you can see that. So pi integral from 0 to L, which is now pi, f at x. Where is our f at x? Our f at x is absolute of x plus 1 multiplied by sine. You see, if I put the pi here to be pi pi, that will cancel out, leaving nx dx. Now, someone might ask how to integrate this. If you don't know how to integrate it, move to my previous videos to see how this thing is integrated. But I'm going to show you. This is product, right? So when it comes to integration, we use what? So when it comes to integration, you use integration by parts, right? So we are going to use that one. I told you that I use u and what? V. The one that can easily terminate to 0. We put that one as the u side. The one that cannot be terminated, you put it at what? The v side. The u side is where we differentiate, and the v side is where we integrate. Now when we differentiate x plus 1, you get 1. If you differentiate 1, you get 0. How many times that differentiated before it's terminated? It was 2 times. So here I have to also differentiate this one 2 times. Sorry, integrate it 2 times. When you integrate sine, it gives you negative cos. So here will be negative cos nx, right? Over the integral of, the differential of nx. That will give you n there. Because if you differentiate nx, n is constant, x will give you 1. So you get this. Now we are going to integrate this again. If you integrate cos, it gives you positive for sine. So still the negative will maintain. And this will give you sine nx, all divided by another n will come and multiply this. That will give you n squared. If I differentiate nx, that will give me n. And already there's n here, so you multiply. So that is what you get. So you said that this moves with this one, this moves with this. You're supposed to do another integration so that the 0 goes with that. By 0 times that will still give you 0. So plus minus. So let's see what you're going to do. Here, I don't know, you cannot just say that, just like my previous video where you take this side to be 0. You know, sine 0 is 0, right? And also, when I put pi here, sine n pi will also be 0. So it means that this one will still be 0. So let's only maintain this one, the cos side. So that's what you're going to do. So you're going to have our bn to be 2 over pi. So this is what I have integrated. And that one is giving me x plus 1 multiplied by negative cos nx all divided by n, 0 to pi. I did not bring the sign because at the end of it all, the sign will be 0. The sign will be 0. So that is why I didn't bring it. So my bn, at this point, I'm going to put pi in there first. Remember, this negative can come here, so I can put negative 2 over pi. If I put pi here, this will give me pi plus 1. Multiplying by cos n pi, and this one is divided by n. Then minus, you see, I have brought the minus here out, okay? So this minus is going to affect everything here. So here is going to be, if I put 0 here, this will be 0. 0 plus 1 is 1. 1 times this is the same thing. So what I'm going to have here is cos. If I put 0 here, that will be n times 0. That will be 0. Cos 0 over n. So this is what you are going to get. Let me clean this side. Now we know that cos n pi is negative 1 to the power n. So what I'm going to do here is that we have now is negative 2 over pi. Now already have pi plus 1. So pi plus 1. And cos n pi over n. N pi is negative 1 to the power n, right? So negative 1 to the power n. Remember, this one is dividing by what? N. Then this place will be cos 0 is 1. So 1 over n. So minus 1 over n. You can leave it like this, or you can find LCM. If you find LCM, you're going to have bn equals negative 2 over pi plus 1 negative 1 to the power n minus 1 all divided by what? N. So this becomes the final answer for bn. So therefore you substitute. This is the formula. So x plus 1 will be approximately 2 the summation n equals 1 to infinity. Now our bn is the whole of this, which is negative 2 over pi plus 1, negative 1 to the power n minus 1, all divided by n. Then sine n pi. So the pi will cancel this L because the L is pi. So nx. So this becomes our Fourier sine. That becomes it. So this is the answer you are going to get for the Fourier sine. Is that okay? Thank you. Now let's look at the Fourier what? Cosine. Is that okay? So for the Fourier cosine, we know that Fourier cosine of x is given as the a naught over 2 plus summation n equals 1 to infinity an cos n pi x over what L. So you need to find a naught. So our a naught is going to be 2 over L, right? But here the L is given as pi, so pi integral of 0 to pi the function f at x, which is x plus 1 cos. Now it's supposed to be n pi x L, but because the L is pi, here you have nx, then dx. Someone might say that this is odd function, but it's not treated as odd because of the absolute, okay? So it's not treated as odd function. So you should take note of that. Now, oh sorry, this suppose I don't need to bring the cos nx because this is a naught. So here is supposed to be just like this. Then I will integrate this, right? So I'm going to have a naught equals 2 pi. So if I integrate this, I have x squared over 2 plus x 0 to pi. So my a naught will be 2 over pi. Now if I put pi here, that will be pi squared over 2 plus pi minus 0. Because if I put 0 here will be 0, here will also be 0. So it will be like this. So my a naught will be equal to 2 over pi squared over 2 plus pi. Now here you can find LCM, right? If you find LCM, we are going to have a naught to be equals to, the LCM will be 2. So I'm going to have 2 over pi pi squared plus 2 pi all divided by 2, like this. So these two will go with this one. And here if I factorize pi out, I have a naught equals pi out. Sorry, now I have 1 over pi out pi plus 2 all divided by, sorry, already I've cancelled out the 2 already. So my a naught is going to be, this cancel this, will you have pi plus 2. So this becomes my a naught. Now the next thing is to find what a n. So let's write our a naught somewhere so that we did not forget. So we have our a naught to be pi plus 2. Having we done with the a naught, we move to a n, right? And you know that the a n will be 2 over L, but here is 2 over pi because L is pi. 0 to pi. Then the function, which is x plus 1, right? then cos nx dx. So you're going to integrate this integration by parts. So I have my u here, I have my v here. The u is x plus 1, which I've already explained why I am choosing it that way. Then cos nx. If I differentiate this, give me 1, then 0. I differentiated it 2 times, so I will integrate it 2 times. This will give me 1 over n sine nx, right? The next one gives negative 1 over n squared cos nx. This will go with this will go with this, plus minus. Now let's look at something here. For the sine, it will go to 0, so we won't use it. So we move to the cos. Now negative multiply negative, that gives you positive. So here, when we integrate this, what we have is that you have 2 over pi 1 over n squared cos nx 0 to pi. So my an equals 2 over pi. If you look at this one very well, if I put pi here, you remember I'm going to have 1 over n squared cos n pi, right? Minus 1 over n squared cos 0. Because if I put 0 here, that makes everything 0. So this is what I have. That is perfect. Now, cos 0 is 1. Cos n pi is negative 1 to the power n. I have already explained this one in my previous video. So you can go and check for it. Okay, so we thank God that this is what we have now. So what we have is that our an, which is equals to 2 over pi, here will be 1 over n squared, multiplied by cos n pi. By cos n pi is negative 1 to the power n over the n squared. Okay, here will be cos 0 is 1, so at the end I have negative 1 over n squared, like this. So in this case, if I'm to find the LCM, what I'm going to get is an equals 2 over pi negative 1 to the power n minus 1 all divided by n squared. So this is what I have. Okay, so you have a naught, you have an. So you're going to substitute. Is that okay? So f at c of x, which is equals to x plus 1, which will be approximate to a naught. We had pi plus 2, so pi plus 2, but remember a naught is dividing by 2. Then plus summation as n goes to 1 to infinity. Our an is the whole of this, which is 2 over pi negative 1 to the power n squared, to the power n minus 1 all divided by n squared. And remember, the whole of this is multiplying by cos. Because of the L, it will be cos nx. So this, let me bring it down, multiply by cos nx. Is that okay? So this becomes the final answer for the Fourier cosine. Thank you very much for watching. Please try to share, like. Thank you.